The power of the Unix shell comes from the versatility with which we can combine together various commands. This includes mainly the so-called command pipelines, a convention to see whether a command succeeded or not, the ways to check that, and also ways to group commands together. The most amazing feature of the Unix shell is the ability to join commands together into a pipeline. This has the output of one command become input to another one.
Let's first have a look at the word count command wc, which counts the number of lines, words, and characters of a file. It informs us that the file etc.motd, which contains the message of the day, consists of 7 lines, 40 words, and 286 characters. Next, let's look at the output of ls/etc after redirecting it to a file named files. We can count a file's elements by providing it as standard input to wc. To count the number of files in the etc. directory, I specify the option -l to wc, which counts the number of lines. We see that there are 203 lines in files, or in other words, 203 files exist in the directory etc. I can now combine the two commands and have the output of ls sent as input to wc by joining them with a pipe symbol, which is represented by the vertical line. As you can see, combining the two, we get again the result 203. As another example, I list the USR directory and pipe the output to cat-n, which numbers the output lines. In this way, all files included in the user directory are printed line by line, preceded by the corresponding line number.
When a command terminates, convention dictates that it will return the code of 0 to indicate success and a code different than 0 to indicate failure. Often, sophisticated commands use various numbers to indicate the failure type. So, 1 might mean that the command line options were wrong. 2 might mean that it couldn't open a file. And 3 might mean that it could not connect to a remote host.
Let's first run a command that succeeds. I simply count and print the lines, words, and characters of the file /etc/motd. We can see the result of this invocation, whether it was successful or not, through the exit status, which is stored in the question mark variable. By echoing the value of this variable, preceding it as always with a $sign, we get a value of 0, which by convention denotes that the command terminated successfully. Trying to wc a file that doesn't exist in the current directory results in an error. Now, by looking again at the value of the question mark variable, we notice a value of 1 instead of 0, which indicates that the command terminated with an error. Traditionally, some error codes note specific error cases. For example, 1 may imply that the file was not found, 2 that some options were specified in the wrong way, and so on.
We can combine commands together with a conjunction, an AND, A and B, so that the second command will be executed only if the first one succeeds. Think of rise and shine.
As an example, I first create a file named A-file. Next, I invoke cat-n on A-file and redirect the output to another file called B-file. I then append a second command, rm A-file, with a conjunction, which means that the second command, rm, would only be executed in case the first one, cat, succeeds. Listing now the contents, we see that B-file is present as opposed to A-file, which was removed. On the other hand, consider the following case. Again, I run cat-n on B-file, but this time I miss the dash sign between B and file. So, trying to rm B-file is not executed now because cat fails. To verify that, I list the contents of the directory and see both B-file and C-file present. C-file was created through the cat command, but B-file was not removed.
We can also combine commands together with a disjunction, an OR, A or B. This means that the second command will be executed if the first one fails. Think of leave free or die.
After creating a file, I copy a file to B file, or, in case the copy fails, I echo copy failed. No output is generated because the copy succeeded. On the contrary, if I copy a file to B file, missing the dash between A and file, we get an error from CP. Cannot start a file, no such file or directory, along with the output of echo, copy failed. Since copy didn't succeed, the second command was executed.
The shell also allows us to negate the result of a command's execution. Thus, a command that succeeds will appear as failure, while a command that has failed will appear as success.
In this example, the date command succeeds. However, because I have preceded it with an exclamation mark, the exit status of the question mark variable is the opposite of the command's result. So, instead of 0, the exit status is 1, implying failure. On the other hand, listing a command that fails, such as ls xyzzy, and looking at the exit status variable, we get a value of 0 indicating success.
We can also group together various commands. This is very useful because we can combine their outputs into a single output and redirect or pipe that together as one.
With a semicolon, we can separate commands just as we do with a new line. So in this example, I first print today is, and then the actual date, and both are executed together, providing the result we see. In order to redirect the output of these two commands, I cannot append the redirection to the end of date, since it will be only redirect the output of date. Instead, I can place the two commands in curly brackets and redirect the output of this group altogether. The new result is identical to the previous one, written in a file named timestamp. Similarly to the way we redirect the output of a group of commands by enclosing them in curly brackets, we can also pipe the group to another command. For instance, I send the output of the commands in curly brackets to wc-c to count the number of characters, and we get the result 39. When an open curly bracket is entered to denote the start of a group of commands, we're allowed to type each command on a new line. The shell expects us to complete the whole group, and only after a closed curly bracket is inserted, the group of commands is executed.
This concludes our Foundations unit on command grouping. Stay with us.